Today we're working on the workbook, page 29. So if you have the workbook, open that page, please. If not, you're going to have to use line paper for now and then transfer it over to your workbook when you have it in your hands. We're going to be calculating payments and interests and balances for amortized loans. And in order to do so, we need to have something we're buying so that we need to take out a loan to do so. So this type of amortized loan calculation is done when you're buying houses and cars and like large purchases like business loans, things like that where you kind of take out like a mortgage type loan. And what happens is we are going to look at, let me see if my canvas will work on here. We are going to look at some cars, I believe. And this is on Canvas, so you can open this up. We're going to look at some cars, and then we're going to look at some houses. It would be nice if you guys could pick a car as a group in your breakout rooms and do the calculations for that car specifically, or pick a house and then pick a house and do the calculations on that. Actually, let me just solve that problem for you guys, so you don't have to pick. We're gonna say room 1. We'll do the Tesla calculation. Room 2. We'll do the Chevy Colorado, and then room 3. Since there are 3 rooms, we'll do the Chevy Camaro calculations. Essentially, what you need from this page is the amount of money that the car is worth. So room 1, room 2, room 3. And then as for the houses, let's just have both or all 3 rooms doing the second house. So the $750,000 house. So we're not going to do that one. If you want to practice with the other one after you've done the main car and house, you can still do that. But what we're going to do is we're going to assume that we're buying, let's say, the Tesla for $74,000. We're going to go over to our workbook, and I'm going to write Tesla up here. So I'm going to get started with the Tesla example. We're going to write the initial loan amount is going to be our initial balance. So before we've made any payments on the car loan that we're getting from the dealership, our balance will be the starting price of the car. So $74,000 will be how much we borrow from the dealership or the bank, wherever we're getting the money from. Sorry. And then we're going to do calculations. Give me 1 sec. For an amortized loan, we need to calculate a couple of things. First thing we need to calculate is what the monthly payments are going to be. And how we calculate those monthly payments is this big formula where we have the payment amount times this fraction 1 plus r over n to the nt minus 1 divided by r over n equals p times 1 plus r over n to the nt. I know it's a big formula, but essentially we're going to fill out everything in this box with numbers. Everything in this box with numbers, and the only thing we don't know is going to be this number, this payment number, which is going to be our monthly payments. And that monthly payment will be the same for every month. So that will never change for the duration of this loan. What will change, however, during the duration of the loan is going to be the interest amount. And the interest amount, I'm going to write in parentheses each month, because we need to calculate the interest amount for each month as we're filling out our table. And for the interest calculation, we're just going to use our typical interest formula, which is I equals P times R times T. But a couple of things to note here is that P is going to be the previous balance. R will be the rate, and time will always be 1 over 12, because the time for each interest calculation is 1 month. So we're calculating 1 month's worth of interest whenever we're doing this. In the original monthly payments calculation, this P is the total loan amount R is the rate of the loan, which shows up in multiple places, right? This R, this R, this R, they're all the same R. That's just whatever the loan terms are. T is the length of the loan, which if you look back at page 29 in your workbook, sorry, not page 29 in your workbook. Does it say it on here? Oh, it says it in the handout. It gives you a rate and the number of years that the loan is going to be for. Same thing with the house. It gives you a rate and the number of years that this table is going to be calculated for. So in the handout, it tells you the length of the loan, and it gives you the rate. N, on the other hand, is always going to be 12 for amortized loans. Because of the way they're structured, because you make monthly payments, they're compounded monthly. Monthly means 12, so N is always going to be 12 for these car payments or house payments calculations. Okay, same thing with the R and the N and the T on the left side of the equation, right? I know I've just pointed to like this side, but everything over here is the same as over here. So the R and the N and the T are the same in here and the same in here. I suppose I have time to do an example. So, are there any questions?
I actually have a quick question. Do banks use this formula to maximize profit, or is it just like a formula a consumer would use?
It's not necessarily maximize a profit. What would change their profits would be just like the percent rate that they give. But as soon as the bank tells you the rate and the number of years you're gonna pay the car or the house off in, either the bank or the individual can just like create these tables. And if you ever go to like a mortgage calculator or like a loan calculator online, it'll tell you what your monthly payments are going to be, and that's essentially using this formula and this amortized method. And then whenever you buy a house or buy a car, they'll give you the whole like a whole spreadsheet of like what you're going to be paying every month, what the interest of that is, and what the balance is going to be after every month. So it's not necessarily to maximize interest. That manipulation comes in with the percent rate and the number of years you're borrowing. And usually, the longer the term is, the smaller you can get the percentage to be, because the banks will make the same amount regardless. But it'll be easier to make payments if you divide it into a longer term loan. But yeah, it's a good question. But as soon as you know these terms, the 4.08% over 5 years, and you know how much money you're borrowing, you can just make the table. The bank can make the table. Anyone you give that information can make this table and figure out how much you're paying each month, how much of that is actually going to the car, and how much is just interest going to the bank. Okay. Good question. There was a question about for the monthly payments, do you plug in all the numbers for the left side to get the right, vice versa? Uh, for this formula, we're going to plug in all of the numbers for both sides, except the thing that we don't know, which is the payment amount. And this, I guess we should draw an arrow to it and say this is our monthly payment. And that one does not change for the whole table. That one stays the same. We just fill that straight down the column for monthly payments. But let me give you an example. Let me actually do an example where I calculate monthly payment, and maybe I'll do the interest for like the first month so you guys can see what it looks like. So let me grab one of these tables real quick. Whoa. And throw one down here. And we'll do a calculation. I won't do one of the cars or the houses, but I will do an example where I work with a $20,000 loan. Let's say we're buying a car for $20,000, so that goes there. Nothing goes in the first month as far as the payment, interest, or principal because we haven't made a payment yet, right? Your payments are going to start on month one. So we put the balance. We owe $20,000 as soon as we buy this car. First thing we're going to do is we're going to figure out the payment column because it's going to be the same payment for the whole duration of the loan, and we're going to use this formula here. So we're going to start setting up that formula. Payment times this fraction of 1 plus, I guess since we said this was a car, let me actually copy these down as well. Or was it the 4.08% for 5 years? So let me write that down over here. Buying a $20,000 car at 4.08% for 5 years. So I'm going to use the same numbers that you're going to use in your example, but it's going to be a $20,000 car instead. So 1 plus R over N, which will be my rate, which is 0.0408, over 12, which is always our n, to the nt, which is 12 times 5, because it's 5 years. Don't forget this minus 1. That minus 1 is the most easily forgotten thing in this formula. There's a minus 1 here in the numerator. And then the denominator, we just do the 0.0408 divided by 12. So that's plugging in everything on the left side of the equation. On the right side of the equation, we're going to start with P. P is going to be the amount of money that we borrow for this car, which is $20,000, times 1 plus, again, R over N, so 0.0408 over 12. So we're going to see that show up multiple times in this formula, to the 12 times 5 power again. So the same thing that shows up here, the 1 plus R over N to the NT, is the same thing that's here. Okay, if that helps you remember the formula, you have the same thing in the numerator here as you do on the right side. Just don't forget this minus 1. It's very easily forgotten. Okay, and then we plug, I would recommend plugging all of this into a calculator at once, or maybe at least the numerator into the calculator and the denominator into the calculator, and then plugging all of this into the calculator at once, so that you end up at payment times, if you want to practice this right now, you should get 66.4335 equals 24,517.4782. If you want to practice that right now, I'm going to give you a minute to plug these into your calculator and see if you can get to these numbers. If you have a calculator now, would be a good time to practice that. Okay, and then we're just going to divide the 66.43335 over and get that the payments will be 369.05 when rounded to 2 decimal places. So what we'll do is, once we get that number, that is our payment amount, we can put it in to our table. 369.05, 369.05, 369.05. So the payment does not change for the duration of the loan. We're only doing 3 months of this loan table calculation. This table continues down. Can anyone tell me how many months there will be for this loan? Like, what number do these numbers go to?
Yeah, that's for the total interest at the end of the 3 months.
I know. I'm saying, like, if I know that this table doesn't stop here, right? In real life, well, the table doesn't stop here. We're just only doing the first 3 months of this calculation. This balance is going to go down by a little bit every month, but this table will continue down until 60 payments. Yes. How do we know it's 60 payments?
5 times 12.
Good. Good. The 5-year loan. we're doing monthly payments on it. So 5 times 12 is going to be 60. So after 60, our balance should be at 0, right? The 60th row would have a balance of 0. We're only doing the first 3 months of this as far as the calculations go. Usually you would use some kind of Excel sheet or a Google sheet to calculate, to make the whole table, which makes your life a lot easier. Once we have our monthly payments, now we can start calculating the interest for each of these months. But in order to do so, we're going to need the previous balance to calculate the interest for the current month. So first month interest will be P, which is the previous balance, so 20,000 times rate times time, so times 0.0408 times 1 over 12. Which comes out nicely to 68. Someone in the comments said the calculator yeah, you may have rounded too early if you didn't get the calculation right. Make sure you're keeping 4 decimal places here and here. It's also kind of important how you plug this into your calculator and what kind of calculator you're using. If you're trying to use your phone, you have to plug this in a very specific way. That's why I need you to have a scientific calculator so you can practice this now. If you're plugging this into a scientific calculator, you can kind of plug it in as you see it. But I can maybe help when we get to breakout rooms or something. You can ask me about how to plug this into a calculator. So that comes out to 68, which means my interest portion for the first month is $68. And in general, the principal portion will be the payment minus the interest portion. All right, so we take our payment for this month, which is $369.05. We subtract the 68 from that, and we get our principal portion. So it'll be our payment, $369.05, minus the interest portion, which was $68. So our principal portion is going to be $301.05. And then finally, we need a way to figure out what our new balance is. Let me explain to you what's happening here before I give you the formula for that. I don't want you to think there's way too many formulas here. This should logically make sense to you what's happening here. You're borrowing $20,000. Vera, no. Are you saying 2 out of 12 for this one? No, that still stays 1 out of 12. The only thing that's going to change is the P. It's going to be whatever balance we have here is going to be the P. Otherwise, the rate and the time stays the same because we're just calculating 1 month's of interest every time. So it's 1 out of 12 every time. So when I say, like in this formula, the rate is right, whatever question gives you 1 out of 12 for this one. This is always 1 out of 12. Okay. Going back to what is happening here. We're borrowing $20,000. We're going to pay it off in 5 years. We're going to make 60 payments, right? 60 payments of 369.05. Can someone with a calculator multiply 369.05 by 60 to figure out how much we actually pay for this car? And put it in the chat, or just tell me.
$22,143.
No decimal on that?
Nope.
Okay. So we're actually going to end up paying, like these are going to add up to $22,143. The reason why that's happening is because you're borrowing $20,000 from the bank to pay up for the car, and then you need to pay the bank, but you're paying it slowly over 5 years. So they're going to charge you some interest. The amount of interest they end up charging you is the difference between these two things, right? You borrowed $20,000, but you eventually pay back $22,143. That kind of makes sense. If you borrow money for 5 years, it makes sense that you're paying back a little bit more in total at the end of the 5 years. So that's the big picture of what's happening with these loans. The little picture, what's happening from 1 month to the next, is your payments are going to stay constant for the whole 5 years. You're going to pay $369.05 every month for the whole 5 years. What's happening is they actually kind of front load the interest. So this $369.05 monthly payment that you're making is $301.05 of that is actually going towards the $20,000 you borrowed, and $68 is going straight to the bank as like extra money that you're having to pay because you borrowed the money, right? And these two numbers are going to change as you go down this table. The reason why they're going to change is because your balance is going to decrease as you go down, right? As you pay off some of the car, the money that you owe them reduces, which means your interest is going to reduce as well. So when you make this payment of $369.05, you are paying the bank $369.05, but only $301.05 of that is counting towards this balance that you owe them. So that makes sense that to find this next balance, we are going to do previous balance sorry, I need to leave myself better room. Previous balance minus principal portion, because the principal portion of your payment is the only thing that's going to reduce this balance, right? So if I take my $20,000 and do a little box here, my $20,000 minus whatever the principal portion was for that month, which was 301.05, that will give me the next balance, which is 19,698.95. So that's what goes in the box here for the new balance. So you borrow $20,000. The first month you make a payment of $369.05, but only a certain amount of that, specifically the principal portion, is going to count towards the principal amount. Right? The principal amount was $20,000. It's going to go down only by the principal portion amount. And then we start over. Well, we don't start completely over, right? We don't need to do this part of the calculation ever again. Right? This is only done once. So let me actually make a note of that for you guys. This only once. At the beginning of the problem, we do that once. That tells us the payments column, right? That's going to be the same for every single month. This part that we did where we calculated the interest portion, and then we calculated the principal portion, and then we calculated the new balance. That's going to be a new calculation each month. Right? So for the second month now, we would need to calculate the interest portion by using the previous balance. Here, instead of this, we're going to use the previous balance, we're going to use the rate, we're going to use the 1/12, and get a new interest for this second month. And then once you have your interest portion, you can use your payment and the interest portion to find the principal portion. And then you can use the previous balance and the principal portion to find the new balance. Okay, so that part, this interest calculation, this principal portion calculation, and this new balance calculation, this is the new balance, is going to be done for each row of the table. Okay, I think I've talked enough. Let me